Imagine being able to predict the behavior of an entire cell before doing a single experiment. Imagine a world where artificial intelligence accelerates scientific research to levels never seen before. It's not science fiction, it's the present. And if you're a researcher, academic, or graduate student, this could transform your career forever. Today, we are going to analyze the most revolutionary ideas from Dennis Hassabis' conference. The brain behind DeadMind and how you are can directly impact your work as a researcher or academic. If you are looking to improve your scientific production and access better job opportunities, this video is for you. Hassabis mentions a dream, the possibility of simulating an entire cell. For a researcher, this means reducing experimentation time, costs, and errors. If you work in biology, you could test drugs before you make it. If you're in engineering, you could predict structural failures without building prototypes. And if you're a social scientist, imagine analyzing thousands of variables without the need for huge surveys. A team of scientists used AI to analyze data from Alzheimer's patients and discovered patterns in brain images that human doctors overlook. Imagine what that means for personalized medicine. For an example, in chemistry, researchers have used YA to accelerate the discovery of new materials, identifying combinations that previously took years in just weeks. In astronomy, thanks to artificial intelligence, exoplanets have been discovered that would have gone unnoticed with traditional methods, allowing progress in the search for habitable worlds. In the legal field, IA is helping to analyze large volumes of legal documents, identifying patterns and precedents in seconds, something that previously took months of manual research. Economists are using AI models to predict financial crises and evaluate the impact of economic policies before implementing them. And one of the most fascinating points of this conference is the debate on classical versus quantum computing. As technology advances, quantum computing has attracted a lot of attention. But do we really need quantum computers to model complex systems effectively, according to Dennis Hassabis, the co-founder of DeepMind? Classical computing, with the right strategy, could solve problems that previously seemed unattainable. This may seem contradictory, as we have all heard of the huge advances quantum computing promises in areas such as molecular simulation, systems optimization, and artificial intelligence. The interesting thing here is that, despite the hype around quantum computing, classical computing is still extremely powerful, with a smarter approach. By using more efficient algorithms and improving hardware, we could tackle very complex problems without the need for quantum, for example, advances in the use of neural networks and deep learning algorithms over traditional computers. They are already demonstrating their ability to predict natural phenomena such as climate or to detect patterns in large volumes of scientific data. If you're a mathematician or physicist, this is an exciting field. Imagine that the right tools could simulate quantum interactions in complex systems without having to use a quantum computer. Such hybrid approaches combining classical computing with quantum algorithms are gaining ground. In fact, many researchers believe that the best advances will not come from one or the other separately, but from the combination of the two. For example, some physicists are exploring how quantum systems can help improve classical simulation algorithms to accelerate discoveries in particle physics. A real case of how classical computing continues to play a key role in research is the recent advance in computational chemistry. A team of researchers used artificial intelligence on a classical computer to simulate molecular drug interactions with incredible accuracy. Not only did this significantly reduce the time required to understand how molecules work in a biological environment, but also eliminated the need for expensive and time-consuming laboratory tests. What previously might have taken years to test in an experimental setting can now be simulated in weeks, speeding up the discovery of new drugs. This is a big win for classical computing, proving that we don't necessarily need a quantum computer to transform the research landscape. However, in some areas of science, quantum computing could really have the power to change the rules of the game. For example, in materials research, quantum simulation has the potential to revolutionize our understanding of quantum states of matter, which could lead to discoveries in superconductors or next-generation batteries. It is true that quantum computing still faces great challenges. Despite impressive advances, such as Google's 2019 achievement of quantum supremacy, quantum computers are still in their early stages. They are being developed for very specific and limited tasks, and the cost of building and maintaining these machines is considerable. Furthermore, quantum algorithms, while promising, are not always ready for large-scale applications. In the current field, large technology companies like IBM, Microsoft, they're investing heavily in quantum computing. IBM, for example, is working on its IBM Quantum Coming Bar, a quantum system that promises to significantly increase quantum computing capacity in the coming years. On the other hand, some startups such as Riget and Computing are designing hybrid solutions that combine quantum and classical computing, which may prove to be a more viable approach in the short term. In short, while quantum computing has the potential to transform the scientific research landscape, it is essential not to forget that classical computing remains incredibly powerful in many fields, such as artificial intelligence, biotechnology, and materials physics. Classical computing, with new techniques and approaches, could be sufficient to solve complex problems. It is likely that the key lies in combining both technologies, each in their field of specialization, to achieve even greater progress. But it's not just about theory. We are already seeing how artificial intelligence is implemented in a practical and effective way in a wide variety of disciplines, changing the landscape of research and scientific applications. AI is not just a tool for the future. It is a reality in the present that is transforming the way we work, research, and discover. Let's explore how AI is already making a difference in areas such as medicine, physics, engineering, and the social sciences. In medicine, AI is revolutionizing the diagnosis and treatment of diseases. For example, deep learning algorithms can analyze medical images such as X-rays, MRIs, and CT scans with greater accuracy than human radiologists in some cases. A Google Earth-related AI system called DADMIN has demonstrated an amazing ability to detect eye problems such as diabetic retinopathy and macular degeneration, with an accuracy comparable to that of medical experts. But it goes beyond that. AI is also helping to predict weather patterns and weather phenomena with unprecedented accuracy through the use of neural networks and advanced algorithms. IA-powered predictive models are helping to anticipate hurricanes, heat waves, and rain patterns with much greater accuracy than traditional predictions. In addition, IA is playing a crucial role in genetic research. Today, IA algorithms are used to analyze ADN sequences at incredible speed, allowing the identification of pathogenic mutations, which can cause hereditary diseases, cancer, and other conditions. Using AI, researchers can analyze large amounts of genetic data in real time, something that would be almost impossible for a human. This ability to process big data is hugely accelerating the creation of personalized therapies, which could change the way we treat diseases in the near future. If your research doesn't already use artificial intelligence, you're missing out on a key advantage. The fields of biomedicine, genetics, and pharmacology, for example, are already being transformed by AI. Instead of spending years conducting experiments, AI allows complex simulations and predictions to be carried out with a speed and accuracy that was not possible before. In the field of physics, AI is helping to solve some of the most complex problems in the universe. Researchers use AI algorithms to analyze data from the Large Hadron Collider and discover new subatomic particles, something that would have required thousands of hours of manual work. AI is also helping to model complex quantum systems, predicting how particles behave at levels that previously could not be observed or simulated due to the limitations of classical computation. In engineering, AI is optimizing design and manufacturing processes. AI systems are capable of creating new materials, simulating extreme conditions, and improving the efficiency of structures from buildings to autonomous vehicles. With the help of machine learning algorithms, engineers can predict the durability of materials and detect potential failures before they occur, saving time and money in the industry. And not only the exact sciences are benefiting from artificial intelligence, the social sciences are also undergoing a radical change thanks to the capabilities of artificial intelligence. Historians, for example, have used and to decipher ancient manuscripts that had been damaged by the passage of time, such as those written in faded ink that were previously illegible through advanced image processing and pattern recognition algorithms. Historians have managed to read texts that were previously inaccessible, uncovering unpublished data about past civilizations and changing our understanding of history. A fascinating case is the work done by historians using IA to decipher medieval manuscripts. The ancient texts, which originally could not be read due to ink deterioration, have been digitally restored using AI algorithms, allowing fragments of history that previously remained hidden to be read. This is not only expanding our knowledge of ancient cultures, but it is also helping to preserve these texts for future generations. So, as you can see, artificial intelligence is not only present in research, but it's changing the way we approach the most complex problems in science, medicine, engineering, and the humanities. The ability to process large amounts of data, making predictions and discovering hidden patterns is opening new doors to innovation and knowledge. AI is revolutionizing research in ways we couldn't even imagine a few years ago. What if you haven't yet explored how you can integrate AI into your work? It's time to do it. The research of the future is already being defined by this powerful tool. And you don't want to be left behind. Artificial intelligence is not only accelerating research, but also the way results are published. Platforms like scispace allow academics to find relevant references quickly and automatically, facilitating the writing of high-impact articles. In a recent study, researchers who used IA to analyze data and write articles managed to publish in higher impact journals 40% faster than their colleagues who did not use it. Now that you know these ideas, I invite you to reflect on how I could improve your research. Leave me a comment telling me what area you work in and how you think you could apply these technologies. If you want to learn more about AI tools for academics, check out the videos I have on the channel. Subscribe and activate notifications so you don't miss content that can enhance your career. Remember, the future of science is not only in large laboratories or technology companies. It is in the hands of researchers like you who seek to go one step further and make the most of 21st century tools. See you in the next video. If you want to take your learning to the next level, I invite you to join my community of channel members. There you can access exclusive content such as complete courses and live chat, where you can ask me all your questions. It's a great opportunity to connect with you and other members of the community.